Good day, class. I welcome you all to today's topic titled Substitution and Change of Subject or Formula. So, we are looking at this topic today, and I will want you to pay rapt attention to this topic very well because the more you are going to apply this to so many aspects of mathematics, even at senior level. So, let's move on. Okay. When you talk about substitution and change of subject or formula, there are some keywords there such as formula and substitution. What do you understand by the word formula? Formula are questions containing variables that stand for specific quantity. That is, when you talk of formula, for example, area of a triangle is what? 1 over 2 times base times height. So now, from the formula, we have some variables there. We have base and we have what? We have the height. We can refer to all those letters as variables because they can change at any time. The base of one particular shape might be different from the other. So that is why we say they are questioning containing variables that stand for specific quantity. Now the variables are usually represented by letters, just like the example I gave to you initially. Now, while substitution means to replace one letter or a set of letters in an algebraic expression or formula. Substitution means to replace one letter or a set of letters in an algebraic expression or formula with their numerical values in order to evaluate them. All this grammar that I've been saying so far, let us look at this example 1. I will be able to explain better. Find the value of 3a squared plus 2b given that a is equal to 4 and b is equal to 10. This example 1 is really on substitution. That is mainly applicable for substitution because we have been given that the value of our a is what? Is 4. And the value of the b here is what? Is 10. So anywhere you see a, you are going to represent it with 4. And anywhere you see b, you represent it with 10. Now, let's look at the solution. Substitute the values of a and b in the given equation. 3a squared plus 2b. So I've told you that the value of a is what? Is 4. And the a is squared. So you need to square that 4. Plus 2, b is 10. So you put in brackets 10. When you see 2b, it's not 2 plus b. It is 2 times b. That is the link that connects 2b together. So that's why we are multiplying 2 by 10. So let's move on. 4 squared is what? 16. And 3 times 16 is what? Is 48. Then 2 times 10 is what? 20. Add 48 to 20. What do you have? You have 68. So here we are able to substitute successfully the value of a and b, and we are able to get a value for that equation. Look at this example 2. Substitute and find the value of x when x is what? AC minus b over 3 plus a. We are to substitute given all this value. A is equal to 12, b is equal to 21, and c is equal to 4. Anywhere you see a, it is what? It is 12. And anywhere you see b, it is 21. Anywhere you see c, it is 4. Alright. So and we have AC. A 12 times c. A times c. That is 12 times c. What is c? 4. 12 times 4. Minus b. What is b? The b value is 21. Can you see it here? And 3 plus a. That is 3 plus 12. 12 times 4 gives you 48. And you subtract 21 from it, it gives you 27. And 3 plus 12 is what? 15. When you divide 27 by 15, your answer is 1.8. Is that taken? Okay, let's move on. Another example is here. Evaluate square root of d squared minus 2u when d is equal to 16 and u is equal to 56. So we have been given the value of our d to be 16 and the value of our u to be 56. Let's look at the solution together. Where you see d, is no more d but what, 16, and you put everything you have there, square, you put it on it. Where you see u is no more u, which is 56, and you just substitute it directly. Don't alter anything, just substitute in your value for those letters and solve it. 16 square minus 2 times 56. 16 square means 16 times 16, and that is 256. And 2 times 56 is what? 112. When you subtract 112 from 256, you have 144. So what is the square root of 144? That is, think of a number that when you multiply together gives you 144, and that is what? 12. So the square root of 144 is 12. Is that taken? So we have solved for square root of d square minus 2u. So here are the assignments given under substitution. Please, if you did not understand anything, or if you don't understand any aspect of this, try as much as possible forward your question to my WhatsApp number. 4. The total T of population of city C is connected by the formula T is equal to A square plus B square. Please correct this. Where A is the population in turn A and B the population in turn B. Find the population of city C given A is equal to 5,000 and B equals to 1,650. This is the equation that they asked us to substitute for to get C. The total population is what they refer to as city C. Now, we need to find square of what? A and square of B. What is the value of our A? Our A is 5,000. And the value of B is what? 1,650. As you see your equation here, just substitute in the formula where you have those letters. Where you have A, this is 5,000 squared plus 1,650 squared. When you find the square of 5,000, you have 25 million. And the square of 1,650 is 2,722,500. Add the two together. So the total population is 27,722,500. So this is the total of what? Of the city C. Is that taken? Let's look at this example again. The area of a parallelogram is given by the formula AB sine pi. Find the area of a parallelogram when A is 5, B is 6, and sine pi is 0.5. Now, area stands for A. Anywhere you see A, it stands for area. And the formula is given by A is equal to AB sine pi. Okay, so substituting your formula. A is 5, B is 6, and sine pi is what? Is 0.5. When you multiply 5 times 6, that is 0.5. 5 times 6 is 30. 30 times 0.5 is 15. So this is the area of what? Of the parallelogram. There is an equal to here, please. This is another assignment for you. The two last questions that I treated with you here is more or less like a word problem. Likewise, this is a word problem. So the two examples here is to guide you to see how far you really understand the last two examples given to you. So the second aspect of it is changing the subject of the formula. We have dealt with substitution. So now we want to look at changing the subject of the formula. Now, change of subject requires a rearrangement of the letters in the given formula so that one of the letters stands as the subject. For example, if you have a class rep and one day maybe John stood up and said, Tayo is no more the class rep. John will now be the new class rep. Now, you will replace Tayo with what? With John. In that case, we have changed or we have rearranged the setting. We have represented it with another thing. Are you with me now? So let's look at this example 1. Make R the subject of the formula from V. Here, V is equal to H into bracket R plus small r. Now, here is the equation that they want us to solve to make this R the subject of the formula. We don't want V to be the class rep anymore. We want R to be leading. So we'll try as much as possible to see how we can bring R to stand alone. So here we will need to open this bracket. H times R, which is the capital R, we have H capital R, and H times small r, we have H small r. Now let's take HR capital to the other side. This is plus here, it will change to negative. So we have V minus HR is equal to H small r. So now it's only small r that we want it to stand alone as the rep. So now we will need to eliminate this H from it. How can we then separate this small h from this r? We need to divide both sides by this h. Are you with me? So when you divide both sides by this smaller h, we have V minus HR over this small h is equal to r. Now you can try to factorize by saying V over small h minus HR over small h. You will know that this h will cancel the small h again. So at the end of the day, you will have V over h minus bigger R is equal to smaller r. Please, you can replay this audio again to understand my explanation better. So let's move on to the next example. Example 2. Make n the subject in the expression x is equal to square root of n square minus m square over m. We want to make what? We want to make n, this n that is there, we want it to stand out. Instead of x, we want this small n to come and replace x here. So how are we going to do that? Let's look at the solution. The first thing is to take away this square root. And how can you take away this square root? You need to find the square of both sides. What is applicable to the right hand side is also applicable to the left hand side. So by the time you find the square of both sides, this square will cancel this square root. Then you will have s square is equal to n square minus m square over m is equal to s square. You will see that the square here has turned this our x to s square. Are you there? So now let's cross multiply. So we have s square times m to give us ms square is equal to n square minus m square. By the time this one multiply this s square, 1 under this one will multiply n square minus m square. So we are going to have this equation at the end of the day. So take m square to the other side. That's collect the like terms. Then we have ms square plus m square is equal to n square. We are looking for n, not n square. That means we don't need the square on it. So how can we take away this square away? We need to find the square root of both sides. So find the square root of both sides. If you find the square root of this, we have ms square root of mx square plus m square is equal to square root of what? N square. So therefore, we have what? We have square root of ms square plus n square is equal to n, because this square root has taken away this square. Is that taken? If you want to simplify further, you can try as much as possible to factorize this by bringing out this m. At the end of the day, we have m open bracket s square plus m close bracket is equal to n, this square root again. So I think with this we can still move on to our assignment. So here is another assignment given to you. You can see I've introduced the square root, square of a thing. So try as much as possible. Work it out. Is very simple. Okay. Now let's look at the word problem of subject of the formula. The relationship between the energy E possessed by an object of mass m kilogram traveling with a speed of v of meter per second is given by the formula E is equal to half mv square. All this that I've been saying, the E, energy, mass in kilogram, speed, all this just denotes what thing? Equation of what? Of energy. Energy, which is your kinetic energy, and is equal to half mv square, 1/2 times mass times the velocity. So the question here is express m in terms of E and V. Anywhere you see such a question that they said that they ask you to express a letter in terms of order, that letter they ask you to express is that they want you to make this m subject of the formula. They want the m to stand alone, while all this will be the subordinate. And find the mass of an object whose energy and speed are what? 1800 joules and 24 meter per second respectively. That is the energy. They have given you the speed to be they have given you the energy to be what? 1800 joules. That is the value of E. And speed is 24 meter per second. So now, after when you have already made that m the subject of the formula, whatsoever you are able to get as your equation, you are going to substitute this value into it. So let's first look at the first one before I talk of B. So E is equal to half mv square, where you can also express it as mv square over 2. It's still the same thing. So when you cross multiply, we have 2E is equal to mv square. We have already used these two to multiply the energy. So the next thing is to see how we can make m to stand alone. Then you need to divide both sides by what? By v square. Can you see it here? So which means the value of m is what? 2e over v square. And we have been told that our E is 1800 joule, while v is what? 25 meter per second. So when you substitute in your formula into this equation, we have 2 times 1800 over 25 square. 2 times 1800 is 3600, while 25 square is 652. When you divide 3600 by 652, you have 5.76 kilogram. Your mass is measured in what? Kilogram. So here we have successfully made what? M subject of the formula, and we are able to calculate for the mass that they asked us to find. So let's move on to B. The B question is, what is the energy of an object whose mass and speed are what? 100 kilogram and 30 meter per second respectively. Here you have been given the value of mass and the value of speed. What did they ask you to calculate for? Energy. So that means you are going to make use of the initial formula given to you. So let's go there. So here E is equal to 1/2 mv square, where E is 100 kilogram and V is what? 30 meter per second. Substituting your formula, the values into the formula. 1/2, mass is what? It's not here. Please, this one is mass. Mass is 100 kilogram. And your velocity is what? 30 times 30. So 1/2 times 100 times 900. 1/2 times 100 is 50. And 50 times 900 is 45,000. And the unit for energy is what? Joule. So that is 45,000 joule. Okay. So with this, we have looked at different examples on substitution and change of subject of the formula. So with this, here is the assignment for the week. The time t of oscillation of a simple pendulum is given by this. So read the question, digest it, and try as much as possible to work it out. Okay. So thank you for listening. You are welcome to today's class. So we'll meet next time.